Welcome back to science class. My name is Miss Rillieux, and today we will be discussing balanced and unbalanced forces. Thank you for joining me this week. If you joined me last week, we discussed the 3 types of motion: speed, velocity, and acceleration. So before we start today's session, let's review what we did last week. For our do now today, we are going to complete a graphic organizer on the 3 types of motion from last week. So please grab your notes and let's begin. As we just discussed, there are 3 types of motion. Can you remember the 3 types of motion? Yes, the 3 types of motion are speed, velocity, and acceleration. In the first column, all the way at the bottom, it says this type of motion, no direction is required. So out of speed, velocity, and acceleration, which of the 3 does not require direction? Yes, speed does not require direction. Let's move on to the second column. At the bottom, it says this type of motion, direction is required. Out of acceleration and velocity, which of the 2 requires direction? Yes, velocity requires direction, which means that the last column, we are going to place acceleration. So now that we have our 3 columns labeled correctly, let's work on filling in the rest of the boxes. Let's go back to the first column. The first column says that speed uses blank and blank. So what are the 2 components of speed? Hint, the 2 components of speed make up the formula for speed. Can you remember the formula for speed? Yes, the formula for speed is equal to a distance divided by a time. Therefore, the 2 components of speed are distance and time. So now that we have filled in the entire first column, let's move to the second one. The second one says that velocity uses blank and direction is required. So along with direction, what else does velocity require? Yes, along with direction, velocity also requires speed. But there are 2 boxes, so our answer cannot be speed. We need to break down speed into its 2 components. Can someone tell me what are the 2 components of speed? Yes, the 2 components of speed are distance and time, because the formula for speed is equal to a distance divided by a time. Now, let's move on to acceleration. Acceleration is a change in 2 things. I'm going to move this time one over. Just give me 1 second. All right, so let's continue with acceleration. So acceleration is a change in 2 components. Now, Acceleration, if we remember from last week, means that an object can do one of three things. Can anyone remember the three things that defined acceleration? Yes, acceleration is defined by an object speeding up, slowing down, or turning. Now, if an object speeds up or slows down, what are we changing about the object? Absolutely. To speed up or slow down, that means we are changing the object's speed. The last component of acceleration is turning. So if an object is turning, that would mean that we are changing the object's what? Yes, whenever we turn, it means that we are changing our direction. Acceleration is a change in speed and a change in direction. So let's review. There are three types of motion: speed, velocity, and acceleration. Speed uses distance and time, and no direction is required. Velocity also uses speed and time, yet direction is required. And acceleration is a change in speed by speeding up or slowing down, or changing direction by turning. Awesome job. Thank you for helping me fill in our graphic organizer. So now that we have reviewed what we covered last week, let's get started with this week's material. This week, our focus is TEAC 8.6a, Balance and Unbalanced Forces. Along with being able to identify if a force is balanced or unbalanced, we also need to calculate unbalanced forces and how they impact the speed and direction of an object's motion. Our essential question for today: how do unbalanced forces change an object's motion? The agenda for today. The first thing we are going to complete together is a forces foldable. We're then going to complete the forces graphic organizer along with a Kahoot game, and then we're going to end today's session with some STAR practice questions. Our materials. You will need some paper and a pencil. Very simple. So the first thing you are going to do is you are going to take your paper, fold it in half, hamburger style. Once you fold your paper in half, hamburger style, you are then going to take one half and cut it into three separate boxes so that half of your paper looks like this. You are going to label the top half forces, the middle half balanced forces, and the last square unbalanced forces. So again, to repeat our directions, we're going to fold our paper in half, hamburger style. We are going to take one half, cut it into three sections. The first section we are going to label forces. The second section we are going to label balanced forces. And then the last section we are going to label unbalanced forces. I'm going to give you 30 seconds to create your foldable before we move on. If you're just joining us, we're creating foldables so that we can begin to discuss our TEAC 8.6a, Balance and Unbalanced Forces. You're down to your last 10 seconds to create your foldable. And now you're down to your last 5. So let's begin. So what is a force? A force is two things: a push or a pull. Forces cause an object not only to move, but to stop and to change direction. In physics, a force is anything that makes an object accelerate. So the key to remember is not only do forces make objects move, but they also make them stop and change direction. I'm going to give you 20 seconds to fill in the first section on your foldable before we move on. So whenever you push an object or pull an object, you are putting force on that object. You're down to your last 5 seconds to fill in your foldable first section labeled forces. Let's continue. Same section. Forces occur in pairs. They can either be balanced or unbalanced. And that is what we're going to discuss today. Balanced forces and unbalanced forces. So let's begin with our second section in our foldable labeled balanced forces. So balanced forces do not cause a change in motion. They are equal in size and opposite in direction. If an object is experiencing balanced forces, it is either going to stay still or going to remain moving at a constant speed. The key to remember about balanced forces is that balanced forces do not, key here, do not cause change in motion. 20 seconds to fill in the second section on your foldable labeled balanced forces. We want to underline that they do not cause a change in motion and circle the word change. That's key. They do not cause a change in motion. You're down to 10 seconds to fill in the second section of your foldable. And now you're down to your last 5 seconds. Let's continue. So these are some examples of balanced forces. An airplane in cruising altitude. A person standing on the floor. The floor pushes upward, gravity pushes downward. Both forces are equal. Therefore, the person is able to stand on the floor. The forces on the book are balanced. The book pushes upward, the table pushes upward on the book, and the book pushes downward on the table. These forces are also balanced. The book is not moving, just like the person is not moving, because the forces are balanced. In this last picture, the two people are pushing on the box with the same amount of force. Therefore, the box is not moving. As a result, this box is experiencing balanced forces. Now, although example 1, the man is not moving, example 2, the book is not moving, and example 3, the box is not moving, balanced forces does not only mean the object will not move. In this last example with the airplane is moving. So the reason why the airplane is considered balanced forces because there is no change in the airplane's speed. The airplane is not speeding up. The airplane is not slowing down. And because the airplane is at a constant speed, the airplane is experiencing balanced forces. Let's move on to the third section in your foldable, unbalanced forces. Now, unlike balanced forces, unbalanced forces always cause a change in motion. Always. They are unequal in size and direction. The key here is they cause a change. When unbalanced forces act in the opposite direction, you will find the net force. The net force is the difference between the two forces. The net force also includes the direction. The direction of the object, it always moves in the direction of the largest force. I know that's a lot to take in, but the key to remember here is that unbalanced forces cause a change in motion. So I'll give you 20 seconds to fill in the third section of your foldable before we move on. Down to your last 10 seconds, you want to write down that unbalanced forces cause a change. They're unequal in size and direction. And now down to your last 5. Let's continue. Examples of unbalanced forces. How many of you have played tug-of-war? In tug-of-war, usually someone wins. That's an unbalanced force. That's because the side of the rope that has the most force will win, because the forces on one side are different from the forces on the other side. Because the two forces are different, one side would win, and this rope would have unbalanced forces acting upon it. Another example of an unbalanced force is this picture of the red arrow and the blue arrow. The red arrow is going up at 400 newtons. The blue arrow is going down at 500 newtons. These two arrows are experiencing different amounts of force. Therefore, they're experiencing unbalanced forces, not equal. 400 is not equal to 500. Let's continue to discuss unbalanced forces. So, unbalanced forces, for example, here we have 3 newtons, and then we have 6 newtons for the blue arrow. So the blue arrow equals 6 newtons. The red arrow equals 3 newtons. These two forces are acting in opposite directions. The red force is moving in the direction of right. The blue force is moving in the direction of left. Because these two forces are acting in opposite directions, we must subtract. And so when we subtract the red force and the blue force, we will get a net force of 3. And remember, forces always move in the direction of the largest force. The blue arrow was at 6 newtons. It was the largest force. Therefore, we're going to move in the same direction of the blue arrow, but this time at 3 newtons. So the answer to this question is 3 newtons to the left. Another example of unbalanced forces. Here, the red arrow is smaller, therefore it has a smaller force. The blue arrow is larger, moving to the right. The red arrow is smaller, moving to the left. Because the arrows are moving in opposite directions and they are unequal, the object is going to move in the direction of the larger force. The larger force in this example is the blue arrow moving right. Therefore, these two people will move towards the right in the direction of the larger force. So 4 newtons to the left, 10 newtons to the right. They're moving in opposite directions, so we are going to subtract. That is going to give us a net force of 6, moving in the direction of the larger force, which is to the right. Another example. Now, on this example, we have 2 forces. They are different sizes. So the red one is smaller, the blue one is larger. The difference here is that the red and the blue one are going in the same direction. They're both going towards the right. And so because they're going both towards the right, we have to add them together. And so once we add them together, we'll get a large purple force moving in the direction to the right. All right, so now that we know the difference between balanced and unbalanced force, let's test our knowledge. So we are going to read a scenario, and then we are going to decide together, is this scenario an example of balanced forces, or is this scenario an example of unbalanced forces? So let's start with the first one. It says 10 students are pulling on one side of the rope and 10 students are pulling on the other side of the rope. So first, do we have the same amount of force on both sides of the rope? Yes or no? Yes, we have 10 on one side, 10 students on one side, 10 students on the other side. So we have the same amount of force on both sides. If we have the same amount of force on both sides, is that representing balanced forces or unbalanced forces? Yes, that is representing balanced forces. Great job. Let's do another one. A 200-pound man and a 40-pound child are pushing against one another. So think to yourself, if a 200 man and a 40-pound child, would they exert the same amount of force on each other? Yes or no? No, they would not exert the same amount of force. Who do you think would exert more force, the 200-pound man or the 40-pound child? Yes, most likely the 200-pound man would exert more force. So if one object is exerting more force than the other, is this representing balanced or unbalanced forces? Yes, this is representing unbalanced forces. 40 and 20, those two numbers are not equal. Number 3, a semi-truck and a motorcycle are going the same speed and crash into each other. First question, would a semi-truck and a motorcycle exert the same amount of force on each other? Yes or no? No, they would not, because the semi-truck is much larger than the motorcycle. Therefore, the semi-truck is going to exert more force than the motorcycle. So if the two objects are exerting different forces, does that represent balanced force or unbalanced forces? Yes, that is unbalanced forces, because the semi-truck and the motorcycle are exerting different amounts of force. The next one, 2 twin boys are pushing each other. Will the 2 twin boys exert the same amount of force on each other? Yes or no? Yes, most likely they would exert the same amount of force, because they are twins, which we could assume that they probably weigh the same amount. So if the boys are exerting the same amount of force on each other, are the boys experiencing balanced forces or unbalanced forces? Yes, the boys are experiencing balanced forces. The forces are equal. the forces are equal. Therefore, the boys are experiencing balanced forces. Last two. A boy stands on the floor while gravity pulls him down. The floor pushes up. Is the boy moving? No, the boy is not moving. He's just standing there. So because the boy is not moving and he's standing there, is this an example of balanced or unbalanced forces? Yes, this is balanced forces. Now, if for some reason the boy fell through the floor, then we would be experiencing unbalanced forces. But the boy and the floor are exerting the same amount of force on each other. Therefore, we call this balanced forces. 20 students are pulling on one side of the rope and 2 students are pulling on the other side. Do we have the same amount of force on both sides of the rope? Yes or no? No, we do not have the same amount of force on both sides of the rope. There are 20 students on one side, 2 on the other. And so because we do not have the same amount of force on both sides of the rope, would this represent balanced or unbalanced forces? Yes, this would represent unbalanced forces. Excellent job. So let's get into our game for today. Let's do a couple questions before we get into our exit ticket and end today's session. What is the net force? So what would be the net force on this object? So what would be the net force on this object? 5, they're opposite directions. We subtract, so our answer would be 0. Let's go to the next one. A force acting in the opposite direction of an object. So the force acting in the opposite direction of an object. Yes, it is called friction. Let's do 2 more. What is the net force of an object that is not moving? So what do you think the net force will be of an object staying still? Yes, it is 0. What is the net force on this object? So first, they're going in opposite directions. So I'll give you a hint. We have to subtract. Yes, the net force would be 400. We go in the direction of the larger force, which is going down. So our answer is 400 down. And we'll do one more. Forces can change the blank of a moving object. So what can a force change about an object? Yes, a force can change an object's direction. Very good. So let's move on and end today's session with our do now question, our exit ticket question. Let's end today's session with our exit ticket. So the exit ticket today, I'm going to move me up just a little bit. All right, so the exit ticket today says a toy train engine rests motionless on a track. One student begins pushing the engine to the right with a force of 2. At the same time, another student begins pushing the engine to the left with a force of 5. Which of the following best describes the results of the motion of the engine? So first we have forces going in opposite directions, and we have unequal forces. So just knowing that these forces are unequal, will the object, the engine, stay still if they're unequal? No, they're not going to stay still. And if they're not going to stay still, they're also not going to remain at constant speed. So we can eliminate answers A and C because this train is not experiencing balanced forces. In order to be at constant speed, you have to experience balanced forces. The forces must be equal. These forces are not equal, therefore they are not balanced. So now we have to decide, when we have two forces that are different, what direction does the object move? Does the object move in the direction of the smaller force, or does the object move in the direction of the larger force? Yes, the object moves in the direction of the larger force. The larger force in this diagram is moving towards the left. So we know our answer is B. It travels to the left at an increasing speed. Awesome job. Just to recap, today we discuss unbalanced and balanced forces. Balanced forces allow an object to stay still or remain at constant speed because balanced forces do not cause a change in motion, unlike unbalanced forces that do cause a change in motion. Thank you so much for joining me this week. Have an awesome week, and I will see you next week. Bye-bye.